Welcome back to Climbing the Interface Ladder, lecture number 1, Inventories and Interfaces. So before the break we spoke about various things, how we set up an inventory, how we made a very basic interface. In the end we actually got a working interface. We right-clicked the block and an interface was shown. Well, the block had its inventory, but they weren't linked at all, so we couldn't really modify anything, and we couldn't see the player's inventory either, even though we had a texture showing the slots. That obviously doesn't give us any slots. So the next part is going to connect these two things together and then improve it so we're actually using it properly. So without further ado, let's get started. Oh well, let's continue, rather. So what I'm going to do now is head over to the container. So now we'll see some powerful stuff here for the container. So what we're going to do in this constructor is basically add slots. And these slots will sort of, well, allow us to put things in them. So that will allow the player to actually interact with this interface in quite an easy way, so we don't have to do too much ourselves. So what I'm going to do is start by adding the player's hotbar, the 9 items at the very bottom, and to do so I'm just going to loop through here. So x equals 0 as long as x is less than 9, increase that by 1 each time, and what we want to do is add slot to container. So that's the method we're going to work with, and what we're going to do is create a new slot, like so. And we need to specify a few different things when we create a new slot. What we need is the inventory, so that's the player's inventory, that's easy. We need an ID, and this ID is sort of where in the inventory we can find the item that is being associated with this slot. So what we need here, well, it's just x. So we have 0, 1, 2, 3, 4, and so on up to 8 here. And that's the first 8 items, or well, yeah, first 9 items, sorry, because we started 0, that the player has in its inventory. So the ID has to match that. So there you go. The next part is to define the x coordinates in the interface. Where should this be located? Well, 8 plus 18 times x seems like a good thing. So for each time we increase x by 1, we're going to move 18 pixels to the right, and then we have 8 here where it starts. So it starts 8 pixels from the left, and then we just add 18 each time. An item itself is just 16 pixels, but then we have a border of 1 pixel, so that means that we add 2 to it. And finally we need a y value, and that's going to be 130. So these values that I say, like 8 and 130, that depends on how you've set up your texture, obviously, but that's where they are located in the texture that I'm using, so that's why I'm going to use them. Because it's nice if the functionality, these slots, match the graphics that I've set up in the texture. That's not necessary. You can be very annoying to the user and just have graphics in one location and functionality somewhere else entirely. So you click the slot outside the interface, whereas the graphics is in the interface. That's not very user-friendly, but it's totally possible. Now I want to add the actual inventory of the player, and to do so I need to loop through the 3 different rows of inventory, well, inventory content. Well, the hotbar is also the inventory, of course, but I mean the rest of the inventory, like this, and it's going to work fairly similar. I'm just going to do a nested loop instead, and then we do add slot to container, right, and we want to create a new slot here, in player x plus y times 9 plus 9. So what is this? Well, I need to specify the ID, and I've already used the 9 first up here, so that's why I started 9 here. And then what I want to do is, each time I increase y, I want to increase it with 9 more. So each time I increase it with 9, and then I increase it by 1 for each x. So basically I'm just going from the top left of the inventory and go all the way to the right, the next row all the way to the right, and then the third row all the way to the right with the IDs. And the IDs specify which item to use. So if we specify these IDs wrong, like going backwards or something like that, then what's going to happen is basically that it's going to be rendered in a different way compared to the inventory when you open it normally. So you will see the player, you might see the player's inventory you know, mirrored or something like that, or maybe a scramble. You can randomize these IDs to just scramble inventory. That's also mean. That's not user friendly, but totally possible. Just make sure that you don't have duplicates of the well, IDs. So there you go. So if we run it now, we're not completely done yet, of course, but if we take a look, here we go. So about that. And if we take a look now, we'll see that we have some working slots actually, just because I added them like that. If I right click now, we will see that I can move my cursor here and it will select these ones, and I can actually see, alright, I have the sealer machine there because, well, I have it in my inventory there. If I move it up here, then I can see that it's going to be up here. I can also move it here without a problem. So just because I added those like that and used the IDs properly, I have all these slots here. If I, like I said, made it, well, mirrored it with the IDs, like used the IDs wrong, when I put the item in here and then right click, maybe it would be here, or maybe it would be here, or maybe there, here. It could be anywhere. We could also ignore it completely. So use the IDs properly, and when we use an inventory that we don't know too much about, we might not know how it's supposed to be, but that's why I told you. So we start here's 0, all the way up to 8, and then we go 9, and continue there, continue like so, all the way to that one, and finally this one is the last one. So we don't start at the top there and go there. We start with the hotbar, and then we go from the top. So that's how we do it, and now it's dark. So that's that part, but if we take a look here, these slots doesn't work. They don't do anything, because obviously we haven't specified anything. So we need to do that as well. So how do we do that? Well, in a very, very similar way. So 4 int x equals 0, x is less than 3. And that's good, because the texture has 3 slots, and the inventory that I've specified in the Thailand's machine here also has 3 slots. So, well, that's probably intended, or maybe I'm just lucky. I guess it's the first one. What we want to do here is add slot to container, like before. New slot, and then we want to give it the inventory, remember? And how do we get the inventory of the machine? Well, this is a trick question, because the machine is its own inventory. We implement our inventory there. So it's just a matter of giving it the machine here instead. And the IDs are supposed to refer to the item they refer to. So we shouldn't like, oh right, we do x plus y, well, not x plus y, we do 36 plus x, for instance, because we have 36 slots already, right? Yeah, we do have 36 slots. So we shouldn't do that, because we are in a new inventory. We are using this machine here, so we should start at 0 again. So just x, that's fine, and then we should give it the coordinate as well. 8 plus 18 times x, so the x is the same thing, and I've checked in the texture file that I actually have them at y level 17, so that's why I give it there, that one. And this is everything we need actually, so let's get started. Well, run this, rather. Okay, so now we'll see that we can modify well, the inventory of the contents of this thing. Okay, let's see. Look at that. Now I can actually move things up here. So let's grab some anvils. Remember, we set it so we only could add anvils to it, but as you might have seen, I just put this thing in here. So that's a bit weird, isn't it? And if we grab a hopper and put the hopper here and add the hopper in here, it won't be added. If I add the sealer machine here, it won't be added. If I add the anvil, they will be added. That's weird, isn't it? Another weird thing is if I shift click, then the game will crash. So that's not too good, is it? Well, so let's fix these two things. First we can fix the shift clicking. To make it shift click properly, we need quite a lot of code. So for now, I'm actually not going to show you how to do it. The one thing I'm going to show you is how to prevent it from crashing. We can simply do that by overriding trash the stack in slot and return null. That's going to prevent us from shift clicking altogether, but that will also prevent a crash. We will take a closer look later on how we can actually do the shift clicking work properly. But for now, we're just going to disable it by doing that. The second part, well, that was to well, fix so we only can put anvils in there. So what we have in the inventory itself is to define only accept anvils. And this is used by the hopper, for instance. The hopper asks the tile entity here, oh right, can I put this block in your inventory? And the machine here says, alright, you can do that as long as that item is an anvil. But the player doesn't care about that. The player is just asking the slot, can I put things in here? And it says, alright, yeah, you can. It's an item, you can put it in here. So what we will have to do is specify our own slot and define it so we can only put anvils there. So what I'm going to do here is create a new class called slot anvil. I think that's a good name. Anvil, like so. And the only things we need to do is first extend slot, import that. I said import that, there you go. The constructor. And we have a bunch of things here. We have the inventory. We have the ID. Oops, the ID. We have the X and the Y. And actually, the constructor will only send these to the superclass. I won't do anything more with it. But the important part is the following one here. Is item valid, like that. And this is basically telling us, can we put this stack inside this slot here? And what we want to do is, I guess, return stack is, well, item ID equals block.anvil.block ID, like so. We will just return if you can put it in here or not. Do some imports there, maybe. Oh, I should get banned now. Forgot to equal symbol there. So we want to have a quality check. Not don't want to assign a value. So if the stack's item ID is the same as the ID of the block, the anvil block, then this should be valid. So if we take a look now instead, what we will see is, first of all, that working, and also shift clicking won't crash it. Right. But we will see that we have other problems. We always have problems because, well, why not? So, as you can see now, if I pick up this anvil, oh well, I need some other items. If I try to put this stone in here, it's not going to. Oh, it's working. Oh, I'm silly. Yeah. So we fixed the shift clicking problem. We can't shift click at all. It's not crashing. But well, you're probably screaming at the screen. I've never used it. So what we have to do here is just define slot anvil like so. Otherwise, we're still using the same old slot, and the old slot is obviously allowing us to, well, to add whatever we want. Okay, so I spoke about some problems that we had, and what are those? So first of all, I'm just going to do that we can't put a stone in here. So now I can't put stone in there, but I still can put the anvil. So sorry about that. You obviously have to use the class that you write, otherwise there wouldn't be a reason to write it in the first place. But we have a problem. So let's take a look. Now we have like about a stack in here, like so. I do that, and well, where did my stack go? It's gone. Okay, so we haven't defined a code for saving the inventory at all. We need to save the items of the inventory. So, well, let's do that. How do we do that? Where's our inventory? Well, our inventory is the tile entity. Can the tile entity save things? Yes, of course it can. We've seen that before. So we're basically going to tell it to save its inventory and then load it again. And how do we do this? Well, write to MBT, of course. So that's how we save data. Even though an inventory is much more advanced than just a simple integer, it's going to work in a similar way. But like I said, it's going to be a bit more advanced. Okay. What we want to specify here is something called an NBT tag list. So this is going to be a list of tags, and I'm going to call this items, and we're going to create a new NBT tag list. like so. So I'm just creating an empty list here that we're going to fill with our items. And to do so, we simply loop through our items, like this. Very simple to do. And we also want to get the item at that position. Get stack in slot, like so. And when we've done that, what we want to do is to make sure that we actually have an item. If we don't have an item, there's no reason to save it. So if stack is not equals to null, like so, then we want to save it. How do we save this? Well, we want to have a list of tags up here, so we need to create a tag compound here to save things in. NBT tag compound, and this is going to be the item, and that's just a new NBT tag compound, like so. Okay, and what we want to do is set which slot this is. Set byte. I'm going to call it slot, and then what we're going to have is the integer here, which is what happened here, which is going to be there you go, sorry, which is basically where in the inventory we are at the moment. We need to say where is this item, but we also of course need to save what the item contains, what this item stack is, well, like the item ID, the damage value, the amount, and so on. But we can tell the stack to save that, so we can just refer to the stack and then do write to NBT and then give it the compound. So that would be the same thing as just like calling this write to this write to NBT. That would be totally possible, and the item stack has something similar, so we can just tell it to save it, but instead of using the compound that we usually use for saving, this thing here that we get, we're just sending it our own compound, which it's not going to detect the difference, it's just going to save it normally. So there we go, we set its byte, we write to NBT, and then we do items dot append tag item, like that. And finally, when we're going through all the items, we can just save them all, like doing compound dot set tag items and items. So what we have here is we create a list of tags, we loop through all the items and add compounds to them, then we add that list to the compound we want to save. So what we have here is basically an item can have its own tag compound. So when we do write to MBT, what we're going to save is, for instance, what we're going to save is the ID, the amount, the damage value, and its compound. We're going to save that inside a compound and going to add that to a tag list and then adding that to a compound. So what we have here is a compound within a compound within a tag list within a compound. So it's a bit more advanced than just saving an integer, but in the end it's the same thing. We save things with tags like this, we save the items with items here, and so on. So in the end we just use NBT to save it, but it's a bit more complex. So how do we load it again? Well, what we do is just doing everything reversed. You can call load well, anti-saving, even though you never do, but that's basically what you do. You do the saving but backwards. So that's what we're going to do. So how do we do that backwards, the code that we just did? When we use integers and strings and so on, we just do set integer, and then obviously the backward thingy is to read it while it get integer. And that's sort of what we're going to do, but like I said, it's a bit more complex. So NBT tag list items. So these are the items that we have. But instead of just creating a new list, what we do is get the tag list, like so, from items. There you go. Thank you. So obviously we need to save it to the this item compound rather than the compound up there. Thank you in the chat. Otherwise it would have been a bit messy, because then we would have saved all the items to this compound rather than to the item, which we then appended to the items list there, and then set it to the compound. So thank you, otherwise it would be messed up and I wouldn't have realized what was going on. So what we want to do is get the tag list like so, and when we do so, we want to loop through that. So we, instead of creating a new one and fill it, we want to get the saved one and, well, basically loop through it. So for int I equals 0, I is less than items, dot, what do we do here? Well, what we're going to do is, can I find it? Where is it? There it is. It's called tag count. Sorry. There you go. I was just checking my notes what it was called. So it's not called size. It's just called tag count. So we loop through all the tags, and what we're going to do is just grab the tag at the current position, and we're going to call that item. MBT tag compound. So we need to tell it what sort of tag it is, and then just tag at. There you go. So just grab the current item. So we get all the items, well, the information about all the items, and then loop through all the informations like that. So we get one item at a time. And what we want to do from there is get its slot. So int slot equals item.getByte slot, like that. And when we've done that, well, we can use that for putting it back. But just to be sure, let's make sure that the ID that we get is actually a proper one, so we don't want crashed. Or so we make sure that the slot is 0 or greater, and it's also smaller than the size of the inventory, like that. There you go. And when we have done that, we can just do set inventory slot contents, and we want to do that in the slot, of course. And how do we get the item stack? Well, we could tell the item stack to write itself, so why can't we just tell it to load itself? So load item stack from MBT, and we just give it the item like that. There you go. So what we do here is we save it, we create a list to save it at, loop through the items, and if we actually find an item, then we want to save it. What we do is that we set a slot and then write the rest to it and append that to the list of items. Then we send that list of items, or save that list of items to the compound itself. Then when we want to load it again, we get that list once again. We loop through that list, get the information at that specific index. Then we get a slot, make sure that the ID is a proper one, and then we set the contents of the inventory with that slot and the item stack from the information that we have saved. So we just do saving and anti-saving. We do the saving backwards. Let's take a look. Okay, so now we should see that it is being saved, but the content from the last time is obviously not there because we didn't save it last time. So, well, we didn't have any content there right now. So I'm just going to grab a few anvils, let's put them in there, and we're going to see that we're going to fill up a few anvils here. So let's do like that. So we have an increasing amount there, and we have 7 there. So now if I close it and load it again, we should see that we have that same amount to the left, and then we should have 7 to the right, like so. So now we're saving it and loading it, and everything works properly. So that's very nice, and we're just going to fill up all these anvils. So, well, do we want to check some more issues that we have? Well, let's do so. So take a look here. If I do this and I go into game mode 0, and in here we have about a stack of anvils. If I break it, we didn't get any stacks at all. Why? Well, we haven't defined how it should drop things, so we just remove them and we didn't get them. So that's the next thing we need to fix, to tell it how to drop the content when we break it. So to do so, we want to head over to the block itself rather than the tile entity, so the block machine here. And what we want to do is override a method here called break block, and we have a few different parameters here. And what we have really is the world, we have X, Y, and Z, and finally we have the ID and the metadata of this block, and we can just add them here as well. So we need to do the supercall. The supercall is making sure that the tile entity is being removed, and that's exactly what we want. When we remove a block with the tile entity, we want the tile entity to be removed as well, because otherwise it's just going to stay there and causing issues. But if we remove the tile entity, we won't be able to get the information about what to drop, because that's stored in the tile entity. So what we want to do is do the supercall still, but we want to do it in the end. So we want to add our code before the supercall, and that's totally fine when we do a supercall to a method. If we do it to a constructor, that's not fine. We have to do it in the beginning there, but that's not the case here. So let's define how we drop this. Okay, so what we want to do is get a tile entity at this specific location. We have the world and the coordinates, so it's just fine. Get block tile entity, just like before. There you go. So that's a tile entity. And we might want to make sure that we actually have a tile entity, and we also might want to make sure that we actually have a machine. But just to show you how that in inventories, well, when we work with inventories, we don't really care what type of inventory we have. I'm going to do this a bit differently. I'm not going to check that this is a machine. I'm going to check that this is an inventory. I don't care if there is something else. We can still drop its content. So what I'm going to use here doesn't have anything to do with the machine itself, but the fact that the machine is an inventory. So if it's an inventory, then we can use the proper methods, because we want to use them from the interface inventory. So now we have this inventory, and then we can operate on that one. We want to drop the contents of it on the ground. And how do we do this? Well, we obviously need to go through the content by, well, doing it like this. Inventory.getSize inventory, like so. There you go. And what we want to do next is get the stack at that specific location. Like I said, we want to go through the inventory. .get stack in slot on closing, actually. Oops, messed up there. On closing. So we want to get a stack, but just to make sure that we don't leave it behind, we remove it there. Obviously, when we break the block, it's probably going to be removed anyways, but just to make sure, what we want to do is grab a slot, and we don't want to leave it behind, because if we do, and someone else, some mod or something else entirely, is doing something just as we're doing things here, we're going to drop it, and then that mod is going to keep it as well. So what we want to do is to make sure that when we pick it out, we want to remove it right away to lower the risks of issues, so no duplications here. So grab it, but also remove it, and that's exactly what we do with get stack in slot on closing. So now when we have the stack, we just want to make sure that we actually have a stack, so if it's not null, like so. What do we want to do? Well, we want to spawn this item in the world, and when you drop an item on the ground, you don't drop the item, you created an entity and drop that one with information about the item. So if we have a block, if you have a dirt block and drop it on the ground, what you basically have is a entity with an item that refers to the block. Remember, if we have holding a block in our hand, then that's an item really that refers to the block. And if we drop something on the ground, that's an entity that refers to an item. So, like I said, an entity referring to an item referring to a block. But that's not really too important. The important part here is that we want to create an entity that is being put into the world. And to do so, we need to define its location. Where should we put it? And I'm just going to give it a random location here, x plus the next float. Of course, we could do this with doubles, but I think float is precise enough, so I'm not going to bother about defining this with doubles. World.rand.nextFloat spawn c equals c plus world.rand.nextFloat, like that. And what we want to do next is entity item dropped item equals new entity item. So we want to create a new entity that we want to drop in the world, and what we need to give it is the world, we need to give it the coordinates we want it to spawn at, and finally what we want to do is give it the item, the stack that it should, well, basically contain, you could say, like that, and we just import that. There you go. So what's the next thing to do? Well, we want to set its motion. We want it to fly somewhere. So it would make sense to, I guess, do minus 0.5, and I'm using floats here as well. I think that's precise enough, but you can of course use doubles. That's totally fine because it's actually going to store it as doubles. So that's the motion there, and I wanted to go upwards no matter what. That's usually how you do it. So let's add 4 to a random number here instead. The minus 0.5 is of course to make it go in both directions, or any of the two directions. Dot motion c like so equals minus 0.5 plus world dot rand dot next float. However, this is not going to work at all. This is going to make the items flow, well, not flow, but fly like 10 blocks away or something like that, because these motions are quite big for these items. They are just going to fly away. So what I'm going to do is define a multiplication number here that we're going to multiply it with, and the reason why I do so is just to decrease these values. I still want them to be of this well, this shape that we have, like minus 0.5 plus 0 to 1, to give a random number between minus 0.5 and plus 0.5, but minus 0.5 and plus 0.5 are just too big, so we multiply them like this. So we still get the same sort of relation between these numbers, how they are randomized and so on, but we make them much smaller to make it look much better. Otherwise they will just fly away, and we might find them like 10 or 20 blocks away, and we didn't even saw them fly away because they flew away so fast. So like that, just defining a random position and a random motion. And finally we want to put this into the world dot spawn entity in world. Drop item. So some inventories, I know that some vanilla inventories does this a bit more advanced. What they do is just randomize if big stacks should be split in two, so they can go in different directions. Like if we break a chest with a stack of dirt, it might produce two entity items that it drops in two different directions and so on. So you can totally do that. Like when we get a stack here, we might loop through its content and randomize a number, like, alright, how many items should we remove this time? Like, alright, 20, that's fine, and alright, we have 42 to go maybe, and then we remove 23 this time, and so on. So you can totally do that, but this is a simple version. We just drop them stack by stack instead of splitting big stacks up to drop even more. It doesn't seem that necessary, because also if the stacks are the same and land next to each other, they are going to merge. Well, that's how dropped stacks works these days. So this is how you can do it. Just loop through the stacks, drop them one by one, and then of course we need to tell the tile entity to get removed and all the other standard block breaking mechanics to happen. So let's start and see how it works. Right, then we log in here. Okay, so what we want to do now is obviously place this again. We can add some anvils here, and as you can see, they start to fill up here. And finally, if we break it, we can see some anvils being dropped, and those are the anvils that we had in the slots. So I can also do it like this. I can obviously put them in different slots, because it loops through them all and drops them as different stacks like that, and they are too far away to merge, I guess. So we just got 2 stacks instead of 3, so some of them merged into the same. So there you go. So now we can save them, and we can, well, add them. We can add them through a hopper, we can break it and get them, and it's quite alright. We can't add stone or anything. So the next step would obviously be to use this. At the moment we have it so it drops anvils when we walk on it. That's the functionality from before, but we're not using it from the inventory, and that's the whole point with this. So there you go. Like that. So what we want to do is change how this works. At the moment what we have here is a method called spawn anvil, but we're not spawning, well, we're spawning the anvil alright, but we're not taking it from any inventory. So what I'm going to do here is specify that we want an inventory to take it from, like that. Obviously none of these methods will work now, or all these method calls, because it requires a inventory. Okay, so tile entity, like that, te equals world.get block tile entity, just like usual stuff like that. Get a tile entity. Then what we want to make sure is, of course, that the tile entity is not equals to null, and well, we might want to have the we might check that it's an inventory, or we might check that it's actually a machine here. So as you can see, I'm doing it a bit differently different times, just to show that it doesn't really matter. Usually you would probably use the same all the time, but you know, what I'm showing this time is that it's quite simple. We can have a method that we don't care about what's spawning this anvil. We just want an inventory to take it from. But when we actually want to drop it here, we want to make sure that we actually have the machine itself, like that. There you go. And if that's the case, then we can just give the machine here. It's asking for an inventory, and since the machine is a valid inventory, that's going to be totally fine. So I'm just going to paste this in here, like so. So now we give it an inventory to work with, but we also have this one here, so we need to specify how that one should get the inventory. And to do so, we just use the same, well, the exact same code here. So I'm just going to copy it here. That's totally fine. Like that, and we want to give it the machine. There you go. So there you go. Now we give it a machine to work with, but we're not doing anything with it, of course. So what I want to do is use this inventory here. And how do we do this? How do we make sure that we're using the anvil? Well, we've done this before actually. We just loop through all the blocks to start with, all the items in the inventory to start with. Sorry, like that. That's the same as before. And what we want to do next is get a stack there. Nothing new there either. Got stack in slot, and well, yes, that slot there. Oops. And the next part is obviously to check that we actually found a stack. And just to make sure, let's check that the stack's item ID actually is the same as the anvil, like that. So we have specified that the player can't put it by clicking in there. Well, you can't take a piece of stone and put there. And we also specified that the inventory shouldn't accept anything else, so the hopper won't add anything. But still, that doesn't mean that we won't get anything in there. Someone can still force it into there by having a mod that isn't working properly. Maybe it's not checking things properly. For instance, before the hopper was introduced to Minecraft, and well, I had the cart assembler from Steve's Carts, and you were supposed to give it coal, power, and so on. I forgot to check that we actually had coal in that slot. I just checked that we had something in it, and you just used that. So if you force something else in there, like cobblestone through another mod, like tubes and pipes from another mod, what that would result in would be that we used coal, or we thought we used coal, but what we had was like cobblestone. We forced cobblestone into the slot, but I didn't make sure that we actually had that when I consumed it. So just to make sure, check that it is the correct type. We shouldn't get a problem really, because well, nowadays we have the hopper that forces us to define what should go into it, but just to make sure that we have a proper item here. Of course we need to make sure that it's not null, but this is just an extra check there. Right, so the next thing we want to do is obviously to decrease this, so we remove one anvil there, and since we've specified the code properly, that's going to handle everything else, like if it removes completely and so on. There we want to drop the block, and then we want to return. The reason why we want to return is obviously if we have dropped one anvil, we don't want to drop another one. Let's see how this works. Here we go. So let's take a look. There we go. So now I have 39 in here. If I walk on it, I will see that we have 38 because we dropped it. If I go into the other game mode, so I can grab a few other things, what I wanted to grab is a button, and I also want to grab these cards here. A border card will do just fine. I apply it there, add button, and press it. So now we'll drop that border there, and we'll see that we just had 26 to go. We drop some more, we can see that we only have 14 to go. We drop some more, we can see that we should only have 2 left. Yes, and now if I drop it, we will only see 2. We didn't have any animals for the rest. And if I click it now, we won't drop anything at all. So there we go. We've set up an inventory with a texture here, and well, it works pretty fine, I think. This interface is obviously not advanced in any way at all, but this is the introduction. This is the first lecture. We've set up a proper inventory that works with an interface. We'll take a closer look, like I said, on how to make a more advanced one later on. But that's about it for today, so let's take a close look on what we have learned today. So here we go. We started with how to do an inventory, and basically what we have is well, a tile entity that implements our inventory. We can have an entity that implements an inventory, for instance, for the cart with chests. We can do the same thing with the player's inventory. That's something extra. That's not an entity. That's just the player's inventory there. And when we do implement our inventory, we need to override about 12 different methods, and we have a few of these listed here. We have get size inventory, the get stack in slot, decrease stack in slot, set inventory slot contents is stack valid for slot. But we also have other things like get stack in slot on closing. We had open chest, close chest. So we have a few others we need to implement. Well, override, and you need all those 12, otherwise it won't work. Then we had interfaces. So to make an interface, we need to extend GUI container, GUI screen, or just GUI. And the thing I recommend is GUI container. The other ones won't contain enough information for what we're doing here. And well, in the constructor, we do the super call like that. We give it a container. We create a new container machine with the player's inventory and the machine itself. But we also need to set the size of this interface, and that's of course the size of the texture that we want to use. Then what we have here is well, the actual drawing of the interface. Very simple at the moment, but we're going to see more advanced things in the future. What we have is something called a resource location, and we specify where this resource is located. So that's example there first, and then textures /GUI /machine.png. That's just where it's located, and then we can use that when we draw it in draw GUI container background layer. And what we want to do there is reset the colors just to make sure that everything works properly. And then we want to bind the texture, which is basically a way of setting this is the current texture we want to use when we draw things. And yeah, I know it's a bit weird to remember, or well, tricky to remember what it is, just because we have two methods there that haven't been named yet. So we have Minecraft.getMinecraft.func _110434 _ k, and we have .func _ 110577 _ a, and then we give it a texture. And the reason why they haven't been named yet is because the resource location is something new for 1.6. We had a similar way, you can say, before, but it still worked a bit differently. So now we have resource locations, and that's the way to do it. When we have the correct texture set, then what we want to do is draw a rectangle. And the way we draw a rectangle is define where it should be. That's the two first integers. Then where we get it from, that's the two second ones. And then the last pair of parameters there is the size of it all. So we define the size of the rectangle, where we should put it, and where we get it from. And that's how you draw a texture. Then we had a container, which is, well, the thing that we have both on the client and the server, and some of the things it can do is add slots, but we'll see later on other things we can use it for. What we do here is loop through the hotbar of the player and add a slot for each, well, slot there, basically, and we use a normal slot there. And then we also loop through the slots are our inventory, and in this example here we just use a normal slot, but we saw later on that we added a slot anvil to prevent it from adding anything else at an anvil, and then we obviously made that one as well. Here I haven't added the code for adding the slots for the inventory part of the player's inventory, but it works exactly the same. Here we have the GUI handler that makes sure that we can open the interfaces, and what we will have to do is just implement iGUI handler and then register it by using network registry.instance.register GUI handler, and then we give it the mod and the GUI handler itself. And then we had two methods that we had to override. I removed quite a lot of code here to make it fit properly, but we have getServerGUI where we return the container, and that was returned to the server, and then we use getClientGUI to return that to the client. Right, then what we have here is that slot I was talking about. The only thing we did here was to return if the stack item ID is the same as the ID of the block ID there, and that's just what isItemValid does. It tells us if this is going to be valid for the slot or not. And that's about it. We had a few different things as well. We obviously had saving and dropping and actually functionality as well, but well, those are a bit more specific and a bit longer, so I didn't include them in these summary slides here. So that's pretty much it for this this lecture. Remember, the questions is an exercises document, so questions are there for you to see if you have learned it all. Some questions about how inventories and interfaces works, just a few there. And then we have an exercise and further explorations. Exercises for, well, for you to code some things on your own, and then we have solutions to those in the end. But then we have further explorations, which are a bit bigger. Maybe includes more that haven't been spoken about in the lecture, but a way of continuing. All of these things are obviously completely optional, but I would recommend them. And since you have the solutions in the end of the document, these are not things you're supposed to submit or anything like that. But that's pretty much it. This has been Climbing the Interface Ladder, lecture number 1, Inventories and Interfaces. I've been VSWE, and I hope you enjoyed it. Next time we will take a look on how we can improve the interface. We have a very simple one from this lecture, so we'll take a closer look on the interface itself, but that's next time. I hope to see you then. Goodbye.